We're going to go into further detail of route summarization than I might have mentioned in previous videos, how it helps reduce the routing table size, what auto summarization is by RIP and IGRP, manual summarization, what the null zero interface can do for us with manual summarization, as well as some configuration commands. The whole point of route summarization is to reduce the size of routing tables. Over here on this side of router, we'll call this router A, we've got the 10.1.0.0 subnet. And what happens is they take this one subnet of 10.1.0.0 and break it up into smaller subnets. So you've got 10.1.1.0, 10.1.2.0, 10.1.3.0. So router A will know of all the individual subnets. But as far as router B goes, router B will simply have one routing entry into the routing table of 10.1.0.0. So what happens when any of these routers over here or any computer in one of these destination subnets on this side over here want to send a package to, let's say, a computer with an IP address of 10.1.2.9, the routers will look at it and all of those routers will simply know, hey, anything with 10.1 in it, send it this way. Anything with 10.1 in it, send it over to router A. Then router A will pick up on the fact that there's a 2 in there and go, oh, that's got to go out of this interface. So only router A will have detailed information of where the 10.1.2.0 subnet is. As far as all the other routers are concerned, it's just simply the 10.1 network. As well as router B here, I've broken up a ton of subnets over here. We've got 10.1.3.1 through 10.1.3.10, and I even broke the 10.1.3.10 subnet up into even more subnets using variable length subnet masks throughout all of the broadcast domains on this side of router B. So here's 10.3, 10.8, 10.3, 10.16, and so on. So what could happen is there could be multiple route summarization going on over here if you wanted to. This router would summarize all of the 10.3, that's a 3, not a 10, .10.0 subnets. He'd basically summarize everything 10.3, 10.0 until all these routers, if you have anything that starts with a 10, a 3, and a 10 in the first 3 octets, send it to me. He'll worry about the .8, .16, 24 subnets. Router B will send to router A. I'll say, hey, anything with a 10 and the 3 in the first 2 octets, send it over to me. So as far as router A goes, all of these subnets over here, as well as the subnets of the 10 subnet, they will all just simply have one routing table entry in router A, route summarization. So we're going to take a look at how the different protocols go in and utilize this route summarization. Alright, let's go over RIP version 1, that's the number 1 there, and IGRP. Remember, there's 2 versions of RIP version 1 and RIP version 2. Big difference, RIP version 2 sends the subnet mask along in the routing table update and supports variable length subnet masks. RIP version 1 does not. RIP version 1 and IGRP automatically summarize at network boundaries, cannot turn auto summarization off, and is problematic with discontiguous networks. Spell checker right there. Had to get the spell checker for that one. So it's problematic with discontiguous networks. Let me bring up a diagram so I can explain what I mean. Here's a diagram so I can explain what I mean by these discontiguous networks with RIP version 1 and IGRP. Let's say over here there's like 100 subnets coming off of this router, and all of these subnets are represented by the 10.1.0 subnet. So we've got 10.1.1.0, 10.1.2.0, 10.1.3.0, all the way up through 10.1.100.0. Way over here, for some reason, we've got 10.2 network, and everything starts with a 10.2 And then we got 10.2.1.0, 10.2.2.0, 10, that's supposed to be a 0, 10.2.3.0, all the way up through 10.3 or 10.2.100.0. So we've got a bunch of different subnets going on under 10.2 and 10.1 umbrella. Now, they are both a part of the 10 dot network. So you might think logically the subnets here, and down here would all be a part of the 10, but maybe they're not. Maybe they're a part of the 172.16 network. So we've got 172.16.1.0 subnet right here, 172.16.2.0 subnet, and down here 172.16.3.0 subnet. So the 10 network is separated by the 172.16 network. So that is what discontiguous means. It means it's not all next to each other. So there's part of the 10 network over here, part of the 10 network over here. It's separated by the C of the 172.16.0.0 network. Wouldn't be a problem with certain protocols like RIP version 2, EIGRP, OSPF, but with RIP version 1 and IGRP it causes a problem. Let's take a look at what that problem is. Let's say we have a computer over here. Most of the time he's a pretty happy guy. His IP address is 172.16.3.1. And he wants to communicate with a computer over here with an IP address of 10.1.9.8. So he's on the 10.1.9.0 subnet, and his IP address is 10.1.9.8. And that's this guy. So they want to talk to each other. They're buddies. The problem is router B is confused. And the reason router B is confused is because his routing table is telling him different things. So what happens is router B, or when router A sends his information out to router B about his routing table, all router A knows, or all router A tells router B is, hey, if you want to get, since this is a 172 subnet right here, when he sends the update out, he says, hey, I can get you to network 10. He doesn't put 10.2 or anything like that. He says, hey, if you want to get to network 10, come over to me. I'll get you there. And you will only be one hop away from network 10. So router B has a serial 0 interface, and he thinks he can get to network 10 by going out of serial 0 interface, and it's one hop away. Router C sends his routing table update to him, and since this is a 172 network, and this is called a network boundary here as far as router C is concerned, because he's routing for 172 and the 10 network, he sends an update saying, hey, if you want to get to network 10, this is B's serial 1, you can get there by me. So B will go, oh, I can get to network 10 also through my serial 1 interface, and you'll only be one hop away. So he thinks he's one hop away from network 10 out of either interface. He doesn't know that there's a 10.1 network and a 10.2 network because A and C, since they're running RIP version 1 or IGRP, they summarize the 10 network and just send out the 10. No subnets attached with the class A subnet mask. So what router B is thinking, he's thinking he's got two great paths to get to the network 10, and they're both one hop away. So what's he going to do? He's going to load balance. So when this guy right here wants to talk to this computer over here, router B, left to its default configuration, he'll send some packets out of serial 1 and some packets out of serial 0. So this guy's not going to get the whole message. Router A will get something destined for 10.1 whatever, and he'll be dumping those packets. Just keep dumping those packets. Never going to get there. So some of the packets will make it, some won't. If this path were to go down for some reason, router B would send everything for the 10 network over here, not realizing he can't get to the 10.1 subnet. He'll just think it's all right over there. So they get confused because of this auto summarization at network boundaries. Here's a little bit cleaner version than my previous slide. I was looking at that. It was pretty crazy looking there, so I cleaned it up a little bit. Here's router B's routing table, just to reiterate. Since networks or router C is at what he considers a network boundary, he's between the 10 and the 172.16. Over here, router A is between the 10 and the 172.16. And even though the subnet mask he's using with this is 255.255.0.0, so he knows the 10.2 is a subnet, and he's using 255.255.0.0. When they send that update out to router B, they send it like this: 10.0.0.255.0.0.0. They summarize the entire 10 with that, and same thing with A. 255.0.0.0. So again, in router B's routing table, again, there will be more there than just the 10s. They'll have the 172.16 networks in the router B's routing table. But as far as the 10s go, he'll think he's got two paths. Path 1, out of his serial interface, one hop away, and path 2, out of his serial 1 interface, one hop away. So serial 0 is path 1, serial 1, path 2, and they're equal. So he'll think he can load balance, everything like that. As far as he's concerned, there's no 10.1 and 10.2 separation. Router B is just going to think that there's two ways to get to this network, and they're both equal, so he can load balance across to those. If you were to turn load balancing off, only one of these routes would be used, maybe just this route. So all traffic going to the 10, anything with a 10 would go this direction, even if it was for a machine like over here. So even if it was destined for a machine over here, if load balancing was off, B would just turn it, send it this way. Doesn't matter. It would never get there. So again, with RIP version 1 and IGRP summarizing at these network boundaries, they do not support discontiguous networks, meaning part of the 10 network over here and part of the 10 network over here, separated by the 172.16. RIP version 2 and EIGRP do support this. We can turn off auto summarization or enable or disable it however we want. Let's take a look at that. So like I was saying, RIP version 2 and EIGRP, they send the subnet mask along with the routing updates. Auto summarization can be enabled or disabled, and we can also configure manual summarization if we want to. So auto summarization at network boundaries can be enabled or disabled, and we can configure manual summarization within the network if we want to. So let's go take a look at that. Let me bring up a slide. We'll take a look at it, and then we'll go in and configure it, or I'll show you the commands to configure it on a simulator. Here's that slide again. It shows 10.2 over here, 10.1 over here. 172.16.20.30.10. And again, router A and router C are what are considered network boundaries, meaning between the 10 and the 172.16. If we're running RIP version 2 or EIGRP, we won't have the same problem we run into with RIP version 1 or IGRP. And the reason is we can turn off auto summarization. We turn it off with the no auto summary command. So I can turn it off right here. And what I do is by going no auto summary is I tell router A, hey, when you send the update out, don't summarize it. So when he sends it out, 10.2.0.0 with the /16 subnet mask will show up in router B's routing table. He sends the full mask out of 255.255.0.0 with the 10 and the 2 in there. If I didn't turn off auto summary, then again, this would be 255.0.0.0 and the 2 wouldn't have an effect, so it would end up as a 10 in here instead of 10.2. So router B will know, hey, subnet 10.2 is out of my serial 0 interface, and if we're using RIP, it's one hop away. If it's IGRP, it's a cost of 80,000 something. And he'll know that subnet 10.1.0.0 is out of the serial 1 interface and one hop away if we're using RIP version 1. Again, the cost doesn't matter. The key thing is is that since the mask information is sent out with the update, it's not summarized, the routers can now tell the difference between the 10.2 network and 10.1 network. Router B will have multiple entries in there, but the subnets will be included as part of that entry. So 10.2 and 10.1, instead of two entries for the 10.000 network, it's an individual entry for the 10.2 and the 10.1 network. So now when this guy right here wants to talk to his buddy over in the 10 network somewhere, he sends it out. Router B goes, oh, I can't get there through serial 0 interface. I have to send it out of the serial 1 interface if I want to get to the 10.1 network. And that's with the no auto summary command, if we turn that off at the network boundary. Now within the network, we can also do some summarization. Let me show you that no auto summary command first, and then we'll go take a look at what we would do within the network if we want to do some summarization. So I'll bring up my simulator, and the command that I would do if I had rip running just like we showed in the slide, I would go router rip, and I would go no, and if I forget how to spell it, I can just use my question mark. It's no, and this is the one down here, auto summary. So auto summary turns it off, and now rip will send the mask information along with the update, so I could send information about the subnet instead of just the entire 10 network. Same thing, same command with EIGRP. I just go router EIGRP here with the autonomous system number and go no auto summary. Disables it at the network boundary. I've brought up a different slide here, and as we can see, the 10.3 subnet is broken up into a bunch of smaller subnets. We've got 10.2 right here in the middle. Let me throw some zeros on there. And over here, we've got 10.1.0 or 10.1.1.0 or 10.1.0.0 network with 10.1.1.0, 10.1.2.0, 10.1.3.0. These are not network boundaries right here. These are simply subnet boundaries. This whole environment right here that we're looking at is 10.0.0.0 /8 mask. I just happen to have chopped it up into smaller subnets, and I've even chopped the subnets up. There are multiple places that we could use a little bit of route summarization going on here. It's not necessary for, let's say if there's a router over here in the 10.1 subnet, it's not necessary for that router to have all of these routes for the 10.3 subnets over here. There might be a couple hundred routes for the 10.3, 10.3.1.2.10, 10.3.200, whatever. There might be 200 plus subnets over here. And since the network is designed appropriately, it does not make any sense for, let's say, router A to have every subnet in the 10.3 network. There should simply be one entry, 10.3.0.0. If you have anything with a 10.3 in the first two octets, send it over to router B. Helps minimize the size of the routing tables. Now, since these aren't network boundaries, auto summarization will not have an effect here. So if we want to reduce the size of the routing tables, we can go in and summarize the routing tables ourselves with manual summarization. I could do it here because right here I've chopped the 10.3.10 subnet into multiple subnets. I've got 10.3.10.8's a subnet, .16, .24, .32, and it keeps going, 40, 48. I can keep doing that. So what I should do here is I should summarize and tell all the other routers, hey, if you want to get anything to the 10.3.10.0 subnet or network, just send it over to me. I'll worry about the details. Here for route, and that would cut down the size of the routing tables for all these other routers in here in the 10.3.0.0 network. Over here at router B, we could summarize and tell all the routers, hey, if you have anything with a 10 and a 3 in the first octet, cut that down. Just send it over to me. You don't have to have 200 routing table entries. So we can cut it down to just a 10.3. And if anyone needs to get to a 10.3 whatever, send it over to me, and I'll worry about where it goes from there. Router A, right here, we've got 10.1.10, 10.1.20. That might be 100 plus subnets over here. So what we should do at router A is say, hey, if there's anything with a 10.1, router A tell router B, if there's anything with a 10.1, send it over to me, and I'll worry about the details. Let's take a look at how we would manually summarize that information. So with the cleaner slide again, I'm going to mark the spots where we're going to do some summarization. We're going to summarize here at router, let's call this router, I don't know, D. We're going to summarize here at router B, and we will summarize here at router A. Now at router A, we're going to summarize everything that has a 10 and the 1 in the first 2 octets. So it's going to be summarized with 10.1.0.0. Even though there's 10.1.1.0, 10.1.2.0, 10.1.3.0 subnet, all those subnets start with a 10 and a 1. So as far as the routing table for all these routers go, we're going to summarize it into a 10.1 entry. Router B is going to summarize the information, and that information is going to be as summarized of 10.3.0.0 going out to router A. So anything with a 10.3, router A is going to know to send it to router B. And within the subnets over here at router D, we're going to summarize the 10.3.10 subnet. So there it's going to be summarized, and router D is going to tell all the routers over here, hey, anything with a 10, a 3, and a 10 in the first 3 octets, so that'll be a /24 mask, send it to me. So he'll send that information out to all these routers. So there's a command that we would use to do that, and we'll go into the sim and look at it, but first we're just going to do it in the diagram here. So let's say this is router A's serial 0 interface, this is router B's serial 1 interface, and this interface right here is router D's serial 1 interface. So on these interfaces, we would go in and use this particular command. And I'm going to type this command out because my handwriting is a little bit sloppy. Here's the command typed out. On router A, I would go to interface serial 0, and again, RIP or EIGRP would be running. And I would just type in IP, summary address, and then the protocol. I would just type in RIP if I was running RIP, or EIGRP, and the autonomous system number, which might be 1 or whatever, but I would type in the autonomous system number here. Then I just type in my summarization. So here I'm trying to summarize 10.1.10, 10.1.20, 10.1.30 into one routing table entry. So I would type 10.1.0.0 255.255.00. So what this mask does is it summarizes all of those. It cuts it back and says, hey, only this part is part of the network address. Same thing for router B. IP summary address, the protocol, 10.3.0.0, 255.255.00. This one would be a little bit trickier because I would go IP summary address, the protocol, and it would be 10.3.10.0, and my subnet mask would be 255.255.255.0 because I'm trying to summarize the entire 10.3.10.0 subnet into one entry. The normal subnet mask used out here is 255.255.255.248. So I'm using that, and I dial that back to just this to lump all of the subnets, the 8, 16, 24, and 32 subnet into one routing table entry. So that's auto or manual summarization. And again, auto summarization, we use the no auto summary command to disable it at a network boundary. If we want to do some manual summarization here, we got to remember that these are not network boundaries. This is just simply summarizing within the 10 network. This whole environment is part of network 10.0.0.0. Let's go into the simulator and just look at that auto summary command just so you can see it on the command line, and then we'll review what we've gone over. I'm bringing up my simulator, and I'm going to go in and go to interface serial 0, just like we saw on the slide. This is Palestra 1. And what I do is I go IP, and if I forget, I can just use my question mark. Summary address. So summary address, and then it wants the protocol. Notice I only have two options. RIP, and this is RIP version 2, by the way, or EIGRP. So if I did EIGRP, I'd have to specify the autonomous system number. RIP, and then it wants to know what the address is. So according to our slide, I would put 10.1.0.0 if it was on router A in the slide. This is Palestra 1, 255.255.0.0. If I do a question mark, it simply says carriage return, meaning hit enter, and you're done. So it's a fairly easy command. The main thing is just making sure your IP is planned out appropriately in your network. So here, again, we've talked about RIP version 1, RIP and IGRP. Auto summarization at network boundaries. Again, there can be problems with discontiguous networks. RIP version 2, if we do have discontiguous networks, or EIGRP would be a better option. Can be enabled and disabled at network boundaries, auto summarization can. And manual summarization can be configured within the network if we want to cut down on the size of our routing tables. OSPF we don't have to sweat because our area boundaries it's going to summarize automatically. And again, when we design OSPF, our IP design must coincide with the areas to make it work efficiently. If we do that right, we don't have to worry about it. I have brought up my simulator, and I've gone in and configured it with summarization. So if we do a show run, we can see that at interface serial 0 with an IP address of 10.2.0.1, I have configured a summary address. So I've done a summarization. IP summary address, again, RIP 10.1.0.0.255.255.0.0. On Ethernet 1, I have an IP address of 10.1.1.1 with a 255.255.255.0 mask. Notice the masks. This one is a lot longer. It's a class C mask or a /24 mask as opposed to a /16 mask with the summary address. And that's because theoretically off of my Ethernet 0 interface I might have more routers coming off that interface with a bunch of more subnets that are all a part of the 10.1 network. I've got maybe a 10.1.2 subnet, 10.1.3 subnet, all beyond the Ethernet interface. So I've summarized the whole 10.1 subnet with this command right here. If we look with the RIP configuration, router RIP, I've turned on version 2 so it actually works. Specified I'm routing for networks 10.0.0.0. What I want to show you is in the routing table, show IP route. This extra route gets added in here. 10.1.0.0/16 is a summary, and it says null 0. This null 0 interface is something I want to address, and we have to be able to see it to be able to talk about it. What it is if RIP knows where the destination subnet is, it'll go ahead and send it on its way. So if it knows where 10.1.2.0, it'll go ahead and send it on its way out of its Ethernet 0 interface because that's where it would be in existence. The null 0 interface is there in case this router doesn't know where the destination subnet is. It's basically like the garbage can. It routes the packet to the null 0 interface and it just floats off into space somewhere, never getting to the destination. So it's kind of like it's a garbage can, just tosses it in the trash if it doesn't know where the destination subnet is. That's the whole point of summarization is the next hop router will know that everything with a 10.1.0.0 is on this router or beyond this router. So it doesn't have to worry about knowing where 10.1.10 is. Everything gets sent here. This is the only router that should know the details of the 10.1.0.0 network as well as maybe other routers within it. So null 0 interface is there in case this router doesn't know where maybe 10.1.101 is, the subnet 10.1.101, it'll go ahead and dump it into the trash, and that's the null zero interface. It's kind of like the trash can. So we have talked about route summarization, what summarization is, how it reduces the routing table size, auto summarization, manual summarization within the network, the null zero interface, again kind of like the trash can for the routers, and configuration commands we've used to go over it.